Today we're going to review properties of radicals. And so this is your worksheet for today. It will be graded as a quiz tomorrow. For each, this is broken up into 4 different sections. Each section has video links that you can, actually just website links that you can look at to help you review some of these properties, but I'm going to go over some of them with you right now. So basically, let's just recall, this guy here is called my radical, and the number underneath the radical is called the radicand. The number inside the radical is called an index, but what it actually is your nth root. This one I called nth because the letter n is in there. But whatever number in there is the root of your number. Okay, so in part 1, you're just simplifying, you're finding the nth root. So for example, if I have the square root of 25, the nth root of that, which the square root of 25 equals 5. And that's because 5 times 5, which is 5 squared, equals 25. And when we write a square root, oops, it's zooming out, we know we don't write it in here, but we understand that this is 2. Square root is our second root of the function. Notice I only put a positive 5 and not the plus or minus 5. Because right here we're talking, since we're talking about the nth root, we're talking about the principal root. And principal root just means if it's a square root, it's positive. Because this number 25 is a positive number, 5 is a positive number. What if I was looking for the cube root of negative 27? Well, that answer is negative 3. And that's my principal root because, again, this number in here is negative. And so my answer is negative. So that's my principal root. And this is true because if I take negative 3 times negative 3 times negative 3 3 times, that will equal negative 27. So that's part 1, section 1. In section 2, we are simplifying radical expressions. So, for example, let's say, again, square root of x squared. We know this is just x, and that's true because x times x is x squared. Another way we can look at that is there's a 2 in here, right? And 2 divided by 2 gives me 1, x to the 1. What if I was looking for the square root of x to the 4th? Again, there's a 2 in here. So I can look at this as if my exponent is 4. 4 does divide 2 evenly. This equals x squared. Again, this is true because x squared times x squared equals x to the 4th. What if I took the square root of x to the 8th? Well, again, there's a 2 in here. 8 divided by 2 gives me x to the 4th. And this is true because x to the 4th times x to the 4th gives me x to the 8th. Notice when my exponents are even, they're perfect squares. So what if I had x to the 11th? Well, 11 doesn't divide 2 evenly. So I can rewrite this using an even exponent. I'll say x to the 10th times x to the 1. X to the 10th times x to the 1 gives me x to the 11th. And therefore, x to the 10 is even, so half the 10 is just 5. And I'm left with x under the radical. What if I was looking for the cube root of x to the 6th? Well, using that same technique, I can say 6 divided by 3, well, that gives me x squared. And again, that's true because x squared times x squared times x squared gives me 246, gives me x to the 6th. What if I had the cube root of x to the 11? Well, 11 does not divide 3 evenly, so I would have to break it up. Well, so this is 11, does not divide 3. 10 does not divide 3. Oh, but 9 divides 3. And so x to the 9th times x squared, well, that gives me 11. 9 plus 2 is 11. X to the 9, well, 9 divided by 3, that comes out as x to the 3rd. And I'm left with x squared under the radical. So just one more example. Let's say I have the 6th root of x to the 8th. Well, 8 does not divide 6 evenly, but x to the 6th does, and that would be times x to the 2, because 6 and 2 is 8. And so 6 divided by 6, that's just 1x, and I'm left with x squared. Part 3 is all about rationalizing the denominator. So, this can be a little tricky. Last year, you rationalize things such as 1 over radical x. And when we talk about rationalizing the denominator, we're talking about getting rid of the radical in the denominator. We just want a variable, a number, no radical. So, we know in order to get rid of the square root of x, I can multiply it by the square root of x. But whatever I do to the bottom of my fraction, I must do to the top of my fraction. So I'm multiplying the numerator and the denominator by radical x. And so 1 times radical x gives me radical x. And I know radical x times radical x gives me just x. And so I've rationalized my denominator. So let's focus on how to get something out of the radical. Why does this keep zooming? Weird. All right. So let's say we have square root of x to the, x to the, okay. So suppose I have the square root of x to the 3rd. And we'll put that in the denominator. How can I rationalize this denominator? I want to get rid of the radical. Well, again, I know there's a 2 in here. And so I need this exponent to be even in order for me to get rid of the radical. So I can multiply this guy by just x. But whatever I do to the bottom, I do to the top. And so I get radical x over radical x to the 4th, which is a perfect square. So I have radical x over x squared. I got rid of the radical. Suppose I have the 3rd root of x. Well, in order to get rid of this radical, I need a perfect cube. Well, if this is x to the 1, I'd like to get x to the 3rd, so I can multiply top and bottom by the cube root of x squared.